What is power factor correction? In the last class we discussed. In this class we are going to discuss about power factor correction and what is the rating of capacitor rating. To improve the power factor from 0.6 to 0.9, what is the capacitor size required for one induction motor? Like that, power factor correction, what is the rating of capacitor rating to improve the power factor? That is very important topic we will discuss in this class. Let us start that. Before going to discuss about that, we have to know what is power triangle. Power triangle, everybody knows that. Power triangle, it is the power triangle. In the power triangle, it is a power triangle. From the power triangle, we can predict power factor. Power factor can be predicted from power triangle also. This is at the opposite side, it is adjacent side, it is hypotenuse. Assume that it is an angle. If you assume it is an angle, it is the opposite side, it is adjacent side, it is hypotenuse. This is real power. This is real power. And this is reactive power. Reactive power. This is apparent power. Real power, apparent power, and reactive. Three. For a triangle, how many sides are there? 3 sides. 3 sides how to represent? It is real power in kilowatt, reactive power in kVAr, and apparent power is kV. Simply we can say that it is a power, real power is P, reactive power is Q, apparent power is yes. Apparent power is S, reactive power is Q. Like that you know that power triangle. Power triangle, from the power triangle we are going to derive what is the capacitor size required. That is power factor correction. In the previous, what are the methods to improve the power factor or power factor correction methods we discussed. Now we are going to actual power factor correction. Initially, from the power triangle we can say that it is a power triangle. Or how we obtain impedance triangle, it is another impedance triangle. It is impedance triangle. It is Z, it is R, it is X. It is impedance triangle. This is the power triangle. We can represent this in power triangle also. This is P, this is Q, this is S. It is phi. There is a difference. Power triangle and it is impedance triangle. The same represented here in inverted manner. Actually, like that, if it is an initial power factor, one induction motor, assume that one induction motor is running. Induction motor operating whatever the rating, it is running. What is the power factor of that is 0.6, assume that. If it is a 0.6 cos phi, 1 equal to 0.6. If it is a power factor of induction motor, cos phi 1, initial power factor is 0.6. We want to improve the power factor 0.6 to 0.9. Now assume that the final power factor we want to improve is 0.9. Now phi 1 is, what is the cos inverse 0.6 is, assume that some angle will come. Cos inverse 0.6, what is the value? Cos inverse 0.6 is 0.8 is 36.63. 0.8 is 0.6 is it will go some angle. Assume that phi 1, with the phi 1 we draw one triangle. It is a phi 1, it is a kVAr, it is a real power P. It is a kVA 1 and kVAr 1. This kilowatt. It is kilowatt. We can represent like that power triangle. Initially, what is the power factor? With that, if you draw the power triangle, you can get like this. If you know power P is let P is the power taken by the load. P is some 10 kilowatt, 15 kilowatt. From that, we can represent P equal to 10 kilowatt as well. P is in kilowatt. Let P is the real power taken by the load in kilowatt. P. You know that everybody knows that P is the real power. Real power is mentioned in kilowatt. Now the power factor is 0.1. From the 0.1, 0.6 assume that. Or initially the power factor is cos phi 1. If you don't know this value, initially the power factor is cos phi 1. From that phi 1 you will get. Phi 1 is cos inverse 0.6. What is the value of 0.6? 53.3 degrees. 53.3 degrees. Now this is 53.3 degrees. You will get. We want to improve the power factor 0.6 to 0.9. Cos phi 2 equal to 0.9. From that phi 2 equal to cos inverse 0.9. What is the value of 0.9? Cos inverse 0.9 is 25.84 degrees. From this, it is a now another phase angle is if you improve the power factor, the power triangle will be like this 25.84. This is phi 2. Phi 2 is 25. Phi 1 is 53. Okay. Now improved power factor, due to improving the power factor, the power triangle will be like this. It is phi 2. It is a kVA 1. It is a kVA 2. This is the reactive power supplied by capacitor bank. kVA 2. Assume that it is a kVA 2. It is the reactive power taken by the load. It is the kVA 1 is the total reactive power taken by the load. kVA 1 is the initially what is the reactive power taken by the load. If you improve the power factor, it is a capacitor band rating. Capacitor gives the reactive power. Capacitor band rating is given by. This is the improved power factor. This is assume that it is O, A, B, C. Now kVA rating of capacitor bank is BC. BC we want to calculate. We want to calculate BC1. We want to calculate BC కావాలంటే kVA 1 minus kVA 2 we have to. kVA కావాలంటే which angle we have to take? kVA 1 equal to in this power triangle OAB kVA 1 equal to which we have to apply tan. If you apply the tan theta is opposite side by adjacent side. Tan theta formula is. If you apply kVA 1 we have to calculate. If you apply the tan you will get this. You know already kilowatt in P. It is a P. Let we assume that P is the kilowatt. If you know the value, you can substitute P is 4 kilowatt, 5 kilowatt like that. We are applying tan phi 1 equal to tan phi 1 or theta 1. We can if you assume theta, it is theta 1. Tan phi 1 equal to what is AB by opposite side by adjacent side is OA, where AB is known as kVR1. kVR1 divided by OA is P. OA is the real power. P equal to tan phi 1. Okay. Now from this kVR1 equal to P into tan phi 1. We can represent power into tan phi 1 is known as kVR1. Power into tan phi 1 is kVR1. This we obtained initially. What is the power factor? From that, what is kVR1? If you want to calculate reactive power taken by the load, suppose we have మన ఇంట్లో లేకపోతే ఒక ఇండస్ట్రియల్ అగ్రికల్చర్ ఫీల్డ్లో కానీ ఎక్కడన్నా ఒక 10 కిలోవాట్ మోటార్ ఉంది. 10 కిలోవాట్ ఈజ్ నథింగ్ బట్ P రియల్ పవర్. 10 కిలోవాట్ మోటార్ ఎంత రియాక్టివ్ పవర్ తీసుకుంటుంది? అంటే if you know the phase angle of that one, పవర్ ఫ్యాక్టర్ తెలిస్తే అనేది మనం కనుక్కోవచ్చు. KVR1 equal to P into tan phi 1 is ఈ 10 kilowatt motor ఎంత reactive power తీసుకుంటుంది. How much reactive power will be taken by 10 kilowatt motor? P equal to 10 kilowatt అయితే reactive power KVR equal to P into tan phi 1. Assume that KVR1 is P into tan phi 1. If you know the P real power, if you know the power factor phase angle phi 1, you can calculate KVR1 easily. Now this is the actually capacitor bank rating is this one. If you improve the power factor, the reactive power taken by the load will be reduces. Cos phi 2 is 0.9. From that phi 2 we taken another KVA. Now if you AB minus AC, if you do, then capacitor bank rating will be. Capacitor bank rating is BC. BC equal to AB minus AC. AB minus AC from this power triangle. AB is nothing but total. KVR1 equal to P into tan phi 1 minus AC is KVR2 also you can obtain P into tan phi 2. P into tan phi 2. KVR2 is because it is a total is KVR1. A B is a KVR1. This one is again AC is nothing but it is also KVR. P into tan phi 2. But phase angle we have to consider is phi 2. Phi 2. If you know phi 2 is 25.84 degrees we have to consider. From this capacitor bank rating in KVR, that is KVR rating of capacitor equal to KVR rating of capacitor bank equal to P into, from this equation 1 and 2, assume that it is equation 2, BC is equation 2, assume that from equation 1 and 2 capacitor bank rating or KVR rating of capacitor equal to P into P tan phi 1 minus P tan phi 2. From this equation P into tan phi 1 minus tan phi 2. This is a simple equation to determine the capacitor bank required. P into tan phi 1 minus tan phi 2. That is obtained from power triangle. How the power triangle? If initially what is the power factor? We draw a power triangle. Initially what is the power? Power is constant, but only apparent power and reactive power will be taken by the load will be changes. From this power triangle we obtain capacitor bank rating. This is the capacitor bank rating. Capacitor bank supplied reactive power is KVR P into tan phi 1 minus P into tan phi 2. Okay. Based on this, some problems we will do now.